We share screen. Can you see
Yield forecast?
yield forecast,
Yes.
right? Okay.
Yes.
Yeah. Can you see yield forecast on your screen?
Yes, it is there.
Okay, thank you. Okay. Okay. I will briefly explain how we are doing yield forecast and what we are using for this purpose. We will come to this back again during the yield forecast simulation we will do. So we are using CPT tool, climate predictability tool from AFRIGIST. This is Windows application, and for craft, there was specifically designed the CPT tool for yield forecast simulation. There are different versions. We are using earliest version, as I said, designed for craft. But for your purposes, when you need to do more detailed analysis, you might need to use the latest one. Craft installs that one in the CPT folder. Please do not use CPT folder for that purpose. I mean the installation of CPT itself. More newer ones, you can install it in any other folder. CPT keep specifically for craft simulations. So this is the statistical prediction tool, but it is used also for statistical downscaling. It is designed to produce statistical forecasts, either using GCM outputs or sea surface temperatures. In our case, we will see how to use sea surface temperatures. Very briefly, how we are doing the yield forecast using the CPT and crop modeling approach. Using the crop simulation model, we are simulating crop up to forecast date to this point. Why? Because crop model uses daily weather data. And as usually, daily weather data are available for this type of forecast date. And I'm doing the future forecast. For the rest of the season, we are using historical weather data for same location. If I have 30 years of historical data, then I will select one by one those weather data and will complete starting from the forecast date up to the end of the season with those weather data. Those are historical, right? Last year, previous year, earlier years. So I have those data. Again, up to the forecast date, you are using the current season, current weather data. And then for the rest of the season, we are completing from historical. And in that way, we are getting different yield values. If I have 30 years data, I might get the 29 yield values. This is the step one. This simulated yield values then provides us the set of the yield values that allows to calculate average, YN in this case, and its distribution. So I have the 29 yield values. I can calculate average yield value, and as well, I can estimate the distribution of errors behind this average value. On the next step, I'm fitting those values to statistical model. In this case, multilinear regression equation, and it will be trained using the predictor file. So predictor file selection up to you. In this case, we will use SST, but we are not limiting only use for sea surface temperatures. We can use any predictor file on gridded scale or indexed one. So using that predictor file and yield value and distribution we have, we train statistical model, and then using the statistical model, we are forecasting the yield for the current year. That's very briefly, very concisely, and without any details, how we are doing this one. And then we will do exercise. I will come to this back again. So this approach combines crop modeling on spatial scale, statistical approach, training statistical model using crop model simulation, yield values, and the predictor in order to make the prediction for the current year yield value. Okay, that's very briefly about this. Let me run craft and start next project that will be yield forecasting project. Couple of minutes, 1 or 2, just give me 1 or 2 minutes. Okay, let's start with the new project type, create. This will be the same small region. Yield forecast. From this list, we covered calibration, we covered risk, we come here now the yield forecast. Special resolution 5, same domain. Save. Okay. Crop. Maize. Insert custom. I will use same inputs as for calibration. Field history, initial conditions from the interface. Save. Okay. Next. All inputs are same. Okay. Now here is the important point to mention. As we have available years back to 90s, I will start as early as possible to get the long set of yield values to train statistical model. That's important. It should be more than 11-year simulation and data. I will start from 1983. I think that's I have data. Forecast year will be 2015. Actually, this is ICAS, so we have everything up to 2014 including yield values, calibration, etc. We will do it for the next year, 2015. Forecast date is earliest planting is 19. I will do 1 month later forecast. This will be next month, July 19. Planting was done in June. 1 month later, I will make the forecast. Date of simulation, I will keep as it is. I will save this one and run. Okay, so we are running right now 32 years, starting from 1984, from available weather and information. And forecast year for us is 2015. July 19, 1 month later. This is the first step when we are getting simulated yield values, model simulated yield values. Coming back to this presentation, I'm here now, I'm this process. So I am up to forecast date, July 19. I am using the 2015 weather data. And after the July 19, I will complete weather data from the year 2014. This is 1 round of simulation. After it is done, I will complete that part, 2013 weather data, starting from July to the end, and so forth. So I am getting this way different weather realizations. Every weather contains the up to the July 19, 2000 weather, and the rest of the year data completed from the historical one. In this way, I'm getting the desired values of simulated yield. Okay, couple of minutes. Let me forward meanwhile, and yeah, please go ahead.
Please, I have a question.
Yes.
I'm looking at the forecast date, and it's ahead of the date of simulations. Can you please explain that purpose?
Can you repeat? I was not able to quite catch what you are saying.
The forecast date and the simulation date.
Yes.
Please go over that.
So the simulation date that is mentioned, it is starting point of simulation. So we are starting simulation in June 19. Okay. Forecast date is 1 month later, July 19. We are assuming that for 2019, we don't know whether after July 19. We are at July 19. That's the current forecast date. Okay. And for the rest of the season, we are using the historical weather data, 2014, 2013, to fill that gap starting from July 19 to the end of the season. Does it make sense? Is it clear?
Yes, I'm okay now.
You can repeat if something that you are doubt, then you can repeat your question, put just differently for me.
No, I understand what you're saying. It's just that it is a bit different from something I already know. when you're forecasting like the what do you call it?
So the sense of
The pi CPT, when you're using the pi CPT to forecast. The exit. Oh no.
This should be same. I have the predictant and I have predictor. You can actually use those predictant and predictor. I can show you how you can get the predictant in CPT directly as well in later versions. Is format if the format will allow. The same technique. I have predictant. In this case, this is the gridded yield value. And those value I have 32. And I have predictor, which will contain prediction for 2015, should be there. And then I'm building statistical relations between two of them and making the prediction for the next year. Okay, let me save the results. Okay. Go to the view results. This is our result model simulated values of the yield. Okay. As we are using fertilizers, yield went quite high, as you might notice. So this is the step first in our simulation process, this part. Upload. After this done, the next step will be activated. That means that apply calibration. Before that, apply was the same. Done, apply calibration will be activated. When we're done with apply calibration, climate forecast will be activated. Let me select that option, apply calibration. I will select project, calibration project. It might have several runs. In this case, this is just one. Okay. This is pseudo yield, this is the trended yield, simulated yield, and that's the modification. It's actually one. You can skip or you can apply. Let's apply calibration. Calibration was applied successfully. And we now have the calibrated values. In this particular value of the modification factor, it is same, but some other cases it might be different, might be more or less depending on the modification value. That, as I said, might be more than one or less than one, accordingly increasing or decreasing those values. After this process is done, if we go to the next step, simulation, done. We are here now. This one is activated, climate forecast. Also, please pay attention to what we have here. This field is for forecast, but there are different values there. It was crop model. Now it is calibrated. And after I will select it one change as well. So climate forecast. Yeah, and in this point, CPT will be connected and will be after that working with CPT. So different analysis method in CPT, canonical correlation on PCR. We will select this one by default. I have already predictor file this one to make easy for us to move forward quickly. I will share that one on Google, just in case that you have the example. In the Google, there is a predictor folder, and I will put the predictor there right now. And then we'll explain. Please download from the folder. It is called predictor. And you might see this on my screen. This is knows how CPT works. It was selected as for predictor generation March, April, May pre-season. This is North Atlantic, and the domain that was selected in this area, this is 44 northmost to southmost, minus 44 up to 12. Okay. So I need to enter those values here to indicate this predictor as well. So 44. Indicate predictor first. This one. Missing value, let's assume that 10% values in the predictor file can be missed. You see the predictor file format can be gridded as it is, or can be indexed one. We are doing SST, but you can use any that adheres the format what we have predictor file. And from here, you can generate predictant file, which will be the simulated yield values on gridded base for our case. When you click this one, you can save that file and can use directly with CPT if you would prefer to work with CPT. In this case, it is implemented in CRAFT. It is designed CPT version for CRAFT. Let's move to the next one. Here we need to indicate those extent. Let me check. This should match to that one. -44 2 minus 44 minus 10. And we need also make sure that the length is the same. So it should start from 1983 as well, the predictor. Okay. And I mentioned here as well, linking it back. So we started simulation from 1983. Predictor should start 1983. We've done simulation up to 2014 or simulation. Forecast year is 2015. Predictor should contain 2015 value. That's what we are used for predictor. It builds the statistical relation up to 2014, and then we are using 2015 values to calculation actual yield forecast. Okay, let me with that move forward. I think I hope entered correctly those values. Extents. Next. By default, better to select tree if you have more knowledge about nodes, selection of the different modes, etc., that you can apply, changing those values. Next, as you can see, length of the training period is 32. 83 is the start. And let's run the simulation. And if everything is okay, then we might end up with the results. Okay. Climate forecast is completed. We need to save results. Depending how many years are you simulating, what is your special extent. This step might take more time, especially saving results. But you need to wait patiently until it finishes. Save results completed. Let's go to view results. And this is the final. You see it here? forecast, climate. This is the climate forecast. We had the crop model, we had the calibrated. Now we are at the step climate. And this is the forecast at regional level, done per each cell. An aggregated value. This first value, I suppose, will be the, those are quite close, both. It seems that we have quite close to the normal distribution. I expect this is the yield forecast for 2014, aggregated one. Let's export this aggregation. I'll keep this one as this as well. Let me open that file. This is the aggregated value of the forecast. Compare here. 2022, 13. That one is the aggregated regional yield forecast. And those values we can consider as the distribution of this value, the first value. Although here the years are indicated, but actually those are only labels. From this, you can drive different conclusions. You can build distribution. Is it close to normal or not? You can make the probabilistic estimation, etc. But I will not color this right now. Okay, so this is the, as you can see, the yield forecast value aggregated, and the similar approach you can use at cell levels. You can export grid cell, export a grid, and check and make the further analysis. Any question regarding the yield forecasting simulation and what we've done right now? Please go ahead and ask me if you have any question regarding the yield forecast.
Shadia?
Yes.
Yeah, I have a question. I suppose that this question, I just want to know, in the forecasting process, which kind of algorithm are used to do this?
Well, as I said, we are
Yeah.
using the model simulated values. We are providing this to CPT, and then CPT, climate predictability tool, and statistical package implemented in that one, using the settings like we selected CCA, number
Used
of
what?
CCA, canonical correlation analysis, etc. The settings that I indicated when I went to the forecasting mode. Those are settings, and then it uses internally multilinear regressional analysis. multilinear
Okay.
regressional analysis between predictant.
Mm,
I think I have predictant. I should some second.
okay.
1 second. Let me show both of them. Okay, this is the predictant generated out of crop model simulation. See?
Mhm.
Again, the graded one that generated starting from 83. And this is the predictor, SST.
Okay.
Yeah, using those two, you are building the multilinear regression in order to make forecast for 2015. See, this one ends at 2014 simulated values. So up to starting from 83 up to 2014, those values between predictor and predictant is used to train multilinear regression model. And then using
Okay.
that multilinear regression model, it uses this value, predictor values for the 2015 to produce the next values for the yield forecasting for 2015.
Okay.
So the 2015, those values we are
Okay.
providing to that multilinear regression, and it calculates the values for 2015. See, everything here is generated by crop model starting simulation from 1983 and going up to 2014. Okay, that's how it works. And that's the yield forecast analysis. Now, I put on Google Drive predictor, you might have. Now, in order to generate predictor file, this is up to you to find suitable predictor. Generally, I'm using the CPT version, higher version. I think I have CPT 15 with interface. It's the CPT 15. And to get predictor, I'm using this download option, or you can go to the IRI data library if you are familiar with that one, or you can use this one. So as I'm doing hindcast, I use the SSD from here. Or if you are doing forecast, they are providing GCM outputs, and you can use values from here, among them SSD. Okay. When you come here, then you have option, depending on the version of CPT, select the data source. Okay. Then you can indicate start of the year, 1983 in our case, 2015 will be forecasting. Then you can change these values like March, April, May, averaged in April. Then you can select the subdomain because it has the interface. It's the convenient way to work with. From here, you can define somewhere close the Atlantic as the good predictor, or might be use some other resources to identify the best predictor for your case, just checking on the correlation. That's the domain I will select. Then you can confirm. It will go to the website directly. And from there you can download the predictor file itself. Which may you can come here and you can download. Generally, we are using this older format of CPT because the CPT was implemented in Craft somewhere 2014. But it doesn't matter, it just for formatting are different. So you can download this file. That's the file you can download. And that's all you can use it to predict. Only formatting are different between two of them. Okay, that's yield forecasting. Now, what questions do you have? And then I will show some other things as well. Any question? Now we have time. If you have any questions or if you have any problems and you'd like to clarify how to resolve this one, please ask me and I will try to respond.
Hello, can I ask?
Yes, sure.
Yes, in terms of the forecast, I was a bit confused there. Okay, firstly, is there any validation method that is used to validate the forecast?
Not implemented because in order to evaluate your forecast, you already need to have some results as well, right? But you can work on the hindcast and evaluate and validate in that way. Do the hindcasting first, how it well works, and then you can estimate how it might be in future, or use the forecasting you've done for future as the evaluation method. But this approach itself was evaluated, and there are some publications as well. If you go to that publication that I referenced for Craft, you can find some references there to that approach that combines the crop simulation and statistical approach with CPT.
Okay, yeah, because one other thing that I've realized is does it only incorporate one circulation? Like so you're using the is it the North Atlantic?
But as I said, it's up to you. As example, because this region that I selected is the west side, somewhere for the Atlantic SST, should be well correlated. But again, predictor suitability, this is different topic. And you need to decide what is the best predictor for yield prediction in your case. There are some research and publication on this base, or you can yourself explore and find the suitable predictors. Precipitation might be certain monthly temperatures or SSTs, as in our case. It can be special and use the credit predictor, or you can select indexed one and just try indexed one as well. But again, it varies.
Yeah, that's why I was.
But
Yes,
the
yes.
Craft itself, it's flexible. It provides you the choice. Whatever region you can select. Whatever type,
Yes.
graded or indexed, you can use. And then build that relation that's quite well prove that it works. I mean, the CPT for climate predictability and statistical tool package implemented in it. It's quite well. It works quite well.
All right. Thanks a lot.
Any more question, any more technical problems or anything you might be interested?
Yeah, sure.
Yes, Cyril.
Yeah, I have a technical problem. Like that, I send you an email to know what would be my problem.
Yeah, okay. I want to demonstrate now one additional thing that I did not cover,
Mhm.
and then you can
Okay.
stay on that call, and I
Okay.
will look on your case. Now,
Okay.
I'd like to show you how you can restore craft from the backup you've done previously. And I will use some data set myself that I have. I have some problem moving different monitors, but I will try. Okay, let me close craft.
You need to share your screen.
Okay, 1 second. Can you see the empty screen?
Yes, we can see.
Okay. Now I showed you how you can stop service run, right? You can print in the search about taskbar services. You can go to services. This is the service window. When you press MY, it goes directly to MySQL. And in order to manually manipulate with the database files, you need to stop this one. Otherwise, you cannot access to those files. So we can stop this one. We've done this before. You know about this. I will keep this one here. You remember that some files are hidden. Because of this, I need to make them visible. Okay. Change folder options, view, show. Okay, then I can go to the hidden folder, which is program data. MySQL. I will bring the one more window here. And on C drive, I will create quickly new folder. And I will make the backup of existing one, and then I will restore they craft from some other database. So what I need to copy, this is CCAFS DB folder and IB data 1. I need also to copy this one, Sakusan folder. There are some files that we need there, but better to take all of them. Otherwise, you might miss something. There is one folder I need to copy as well, CCAFS toolkit. And program 86 from this folder. Go to this folder. Find here craft cloud toolbox and this folder. So it's all what you need to make backup of your working. If you have any problem or it's just copy those one. You can restore database and bring them back, etc. Now I will restore cloud database back. How? Let me bring something different that you might notice that how it can be done. I have something here related to the climate change. My temporary folder. Okay. So let's quickly do this. So I need to replace this one. I will delete. I will bring this shape input. One. Next one, I will replace folder that I'm using for crop modeling, right? It's the one I backed up earlier. From CCAFS toolkit folder, we need only this shape version 2. Okay, so I need to bring that one back and And finally, in program data, MySQL. I will replace those two. So what I did, I replaced everything related with current hour work, previously backupping them, and I will put everything that is related with some other project we've done before. So for this, I showed what folders you need to keep. After that, I will start MySQL service. And I will run craft. Now, if everything I did correctly, then we should see something different. One minute, there were changes, so craft is restarting. Microsoft is checking and to configuring the craft. And can you see my screen? Okay, this project was related climate change. Here is the some projects related to that one. What is the different? What we've done so far regarding the climate change? This is to prepare properly weather files. See, climate change, weather data set, that's specifically related with climate change. And then you need to have data sets according to those scenarios. Those are simply labeled. You can consider it like as currently RCPs, just labeled. You just need to know which one is baseline, which one is RCP 4.5, etc. There are 3 scenarios and 1 baseline. Okay? If you prepare weather files properly, upload, then the rest is similar what you've done with our projects we've done so far. Soil, crop variety related data, crop management related data, everything should be done in similar way. Just to show you some results, how everything looks like similarly. If I select any project, let me go to the home page. Let's select this one, for example, the RCP 4.5 on maize, already executed. You can check data sources used. You cannot change them, but you can see. You see soil, climate change, assembly, baseline, crop mask, everything similarly, what we've done so far. And you can see the results on this page. Okay. Now preparing those data, it's weather data is again quite challenging. It's that easy, but it can be done as you can see here. Also, there is a difference among formatting. So if you will select climate change and download template, mention WTG, if you check there, this is not tab delimited. There are points, spaces between column, so you need to consider this one as well. I show those symbols. See, actually, this is might be incorrect. Should be this way. Here is the example. The rest is similar. We need 4 minimum parameters: Tmax, Tmin, precipitation, and radiation. Data format you seen. You can prepare the files in separate files or in one file. Year, 2-digit, and Julian date, etc. Okay, that's regarding the climate change, and you just saw how easily can I restore everything from the backup. I was working with one data set in MySQL and just replacing some folders. I came completely to different project and different setup. In this case, to climate change. Okay, let me stop sharing.